Hi, everyone. This is Adam Griggs from River Network. Just want to thank you all for joining us on the webinar today. We're going to give it about another 1 or 2 minutes to help get people in the room before we get started, and then we'll go ahead and start with the webinar. Thank you. Hi, everyone. Again, my name is Adam Griggs. I'm with River Network and the Water Data Collaborative. It's 1 o'clock, and it looks like we're starting to get people filled into the webinar room. We're going to go ahead and give people about another minute before we get started. But just a couple of housekeeping items. You should be using your computer for audio. If you're having trouble, you can also connect to audio using the provided telephone option. We're going to be fielding questions from the audience today via the chat box. So if you have a question at any time, you can type it into the chat box. We will be having a couple of Q&A sessions. So at the end of the first part of the presentation, we will stop to take any questions that we received up to that point. And then we're going to switch to the second presenter, John Dawes, and we'll be fielding larger questions at the end of his session to cover both portions. So once again, my name is Adam Griggs. I'm the Science Manager for River Network. And this webinar is Conquering Your Data Management Monster. Today's agenda, we're going to do a quick primer on data management, everything from planning and acquisition through to sharing and protecting your data. We're going to look at some of the options that are out there for data management, both software and platforms off the shelf. And then in the second portion of this presentation, we'll be looking at some of the new tools that are being developed to help conquer data management issues being developed by members of the Water Data Collaborative. I want to point out that today's webinar is actually number 4 of a series that's been hosted by the various members of the Water Data Collaborative. We began with an intro webinar, and then we had a webinar on monitoring study design. We held a webinar on looking at a data-rich watershed, building a bridge from monitoring to action. And then today is the last of our 4-part series, which is Conquering Your Data Management Monster. For those of you unfamiliar with the Water Data Collaborative, this is a fairly novel partnership. We've only been in operation about a year. It's a unique partnership because it's a collaborative between a couple of different types of organizations. First, we have kind of the 3 big networks of citizen scientists out there: River Network, ourselves, Isaac Walton League, Waterkeeper Alliance. And this is really to capture the users and the data producers of the NGOs that are on the ground doing a lot of the monitoring across the country. We also have a couple of really savvy nonprofit water technology developers in the Conservation Innovation Center in Chesapeake Commons, who we'll hear from today. And then additionally, forming the initial makeup of the collaborative is also some of the stewards of open data repositories. So these are the folks that actually collect and assemble data and build some of the big data, open data portal resources where all of us can share data and then leverage some of the tools that are built there. So that includes the Duke Nicholas Institute for Environmental Policy Solutions, Colorado Parks and Wildlife, QASHI, which is the Consortium of Universities for Advancement of Hydrologic Sciences, and we also have members of the EPA that sit alongside our steering committee. So the Water Data Collaborative has constructed basically a water science framework that we use for a variety of reasons. This has helped us really map out what are the significant steps that data producers need to take on if they're going to be performing watershed science and really getting high levels of use out of their data. This simple framework should be recognizable to anyone who does this kind of work, from the initial steps of study design and preparing for data collection, through actually collecting and acquiring that data, then having to manage that data, assemble it, assess its quality, before they can analyze or visualize the data, or use that data in planning or modeling exercises, and finally using that data. So sharing it with other data users, using it to guide their actions, communicating science to their general public. At the top of those steps are also, which is kind of a new and opening area for water science, and this is kind of the area of big data. So what happens when you share your data up to open data portals, where this data is now machine readable and can be connected to via a variety of applications that help turn that data into information. We'll learn a little bit more about what's going on in some of these open data portals a little later in the presentation. But we'll keep returning to this framework to kind of keep ourselves organized. And the Water Data Collaborative is what we're really trying to do is take this framework and assess what is the current situation of resources that support citizen science, and where do we perceive that there are major gaps and barriers in some of those resources, or the trainings and the technologies that are currently available. And then we're working to try to fill some of those gaps and remove some of those barriers so that this entire process becomes less cumbersome to those groups on the ground that are trying to do meaningful science and collect rigorous and useful data to help guide their watershed restoration work. So today's presentation, again, we're focusing on data management. I just wanted to stop to talk about the different data types that we'll be talking about. This is specific to kind of water science, but it includes a variety of different data types, whether they're geospatial, chemical, physical type data, habitat data, biological data like macroinvertebrates or fish, or even the data that you might use to track your personnel and your volunteers and your quality assurance programs. So this data management webinar is all about how do we manage data across these different data types in a concerted effort so that we can really get the highest uses out of our data. So data management is really the process by which you plan, acquire, process, validate, analyze, preserve, and share data. It is the whole gamut from step 1 all the way through to step 6. So while we do have data management somewhat acquiesced in that step 3 of this framework, it really is a process that continues throughout it. So step 3 is really where you're doing the bulk of that acquisition and processing and validating your data in a database. But the whole process of data management needs to be one that you consider throughout your process. Good data management should begin with data management planning. And we have sequestered data management planning within our step 1. So step 1 is really where you are doing all of the study design elements that are going to help guide your research and your water data collection efforts. We consider data management planning to be right alongside study design or the development of standard operating procedures or quality assurance project plans. It's really, really important that you identify how you want to be using your data at the very onset of your study design process, so that you don't end up with several years of data and at the point where you're getting ready to analyze it, realize that it wasn't quite set up properly to meet your data uses, your intended data uses. There is one available resource out there that seems to be pretty robust and has had a lot of users. And that's a data management planning tool that's been produced by the California Digital Library. particularly if you need to construct a data management plan, say for sharing data to federal sources. Maybe you've got EPA 319 money or something similar where they are requiring you to have a documented data management plan that's going to help you share that data up to some of the federal portals. That tool would be particularly useful for helping you craft a data management plan. Additionally, as the Water Data Collaborative, we are putting some of our first efforts into the study design realm, and that big step one. And data management planning will be a piece of the resources that we are currently developing and we'll be hosting on the Water Data Collaborative website to help folks tackle some of this strategy, such as data management planning. So data management planning will involve you to answer quite a lot of questions. What kind of data, what are your data elements? So what are the parameters that you are out there collecting? What are the parameters that any intended data users that you might want to use your data that they will require you to collect? Who's going to be responsible for data management? So before you go down the path of trying to get to a data management software or service, make sure that it's matching your in-house skills, or the person who's going to be responsible that is comfortable with the platforms that you're deciding to use and the rigorous data management that's going to be required there. A lot of data of your overall study design and your data management will come from the intended uses of your data. So if you run a program that is designed primarily around, say, public education, and we don't have any intention of using that data for, say, decision-making or sending it over to state or federal agencies, then obviously the documentation of your data is probably less, and you may be interested much more in a streamlined system that will quickly help you turn that data into useful charts or visualizations that you can share back out with your volunteer monitors or the general public. If, on the other hand, you are interested in using your water quality data and leveraging it, say, with modeling data, geospatial data, other available data sets, you want to make sure that you're bringing your data in with the correct pieces of information that will be required to help make that link up to other types of data more feasible. Or if you have the intended use of your data is to be impacting decision-making, if you want your data to be used by local or state agencies in Clean Water Act type regulatory programs, then there's probably going to be very much that you need to do to document your data in order for that data to be trustworthy and understood as far as its quality and how it was collected. We call a lot of that metadata. So that's often a big question that's really going to guide a lot of your data management is really those uses. And if you have external data users, gathering the information from them up front in order to know what elements and what structure you're going to need to include in your data management. You may need to document what resources you have for data management. So whether you have money you can throw at this effort, or if this is something you're going to need to accomplish on a shoestring budget. If your data managers are entry-level staff, what skills do they have? Or if you have a highly technical skilled data management professional, those are different levels of resources that you'll be able to bring to bear to tackle your data management issues. Where you plan to store your data, whether you want your data distribute on just a local desktop, or if you want, say, your data to be on a server where it might be able to be more readily available for external users or online applications, or if you're very comfortable with, say, sharing your data and having it stored entirely in the cloud or at a data service. So these are different questions that you may need to answer that will have some bearing on what types of platforms and software you might be interested in to help you with your data management. Of course, these are not all the questions. We are currently assembling all the types of questions that you really need to have answered in your data management plan. And some of the study design elements that we'll be producing in the next year will really help guide you through all these difficult questions and help you really figure out what it is that's going to work best for your program now and in the immediate future. So one thing that might come out of your questions on what you need documented and the various structure might be data standards. And data standards are your friends. Imagine that you are someone who is assembling data maybe from your volunteers, or maybe for your purposes, you're assembling data that might come from various data producers. So you want to link up your data with state data or county data or some of the federal data that's available. Data standards help, they document what structured data should look like. And this is going to largely maybe take some of the guesswork out of your own work if you need to, if you're coming up with a program from scratch. But also by adopting different data standards, it's going to make your data that much more readily useful to others. So in the example on the left, that's all the same date. There's 6 different ways of entering it. If you had a data sheet with 10,000 records in it and all of your dates look like that, you'd have a significant amount of time that you would have to invest just to get those dates structured into a standard format so that you can then use this for analysis. There are a variety of data standards out there, and it should be pointed out that they can kind of exist at various levels. There may be data standards for an entire field of science. There may be data standards that are put forth for a particular region or a program. There could be standards that are attached to certain protocols or individual parameters, or at the lowest level, even an individual method. So it's important to remember that these standards do kind of exist at various levels. There are a variety of data standards out there that cover data of different types. There are a variety of geospatial data standards, hydrographic data standards like the National Hydrographic Dataset or the Water Boundary Dataset. Aquatic life, in the instance of macroinvertebrates, there's a couple of different standard catalogs out there, but basically they use iterations of taxonomic serial numbers, which are numbers that are assigned to each of those aquatic life species. And that just provides a standard way as maybe Latin names change or lumpers and splitters get in there and decide a certain bug was actually 2. These taxonomic serial numbers help us transfer that data across to different users or combine data that's collected by different data producers into a standard format. There are data standards out there for sharing data of different types. So, for instance, the data that we get out of real-time sensors or loggers often looks very different in its structure, of course, where it's collecting a value perhaps every 10 minutes, every 15 minutes, every hour. That data ends up looking very different than kind of the in situ or ambient data that we might collect on a field visit. So Water ML 2.0 is a recognized standard for sharing that type of data. And at higher levels, the Water Quality Exchange is an example of a data standard. So if you want to have your data show up in the EPA's National Water Quality Monitoring Portal, or in some of the new platforms that are coming out to expose that data in different aspects of our clean water programs, like How's My Waterway? WQX is the standard that you would need to have your data shaped in to be able to contribute it to that large federal portal and have your data appear there and be available for data users and decision makers. You want to consider how you acquire data in your whole data flow as you're mapping this out as part of your data management planning. In some ways, there's no way around the fact that we're always going to be bringing different types of data together. Whether you're out there collecting data on paper data sheets, as so many of us are, then you're going to have that process for doing that manual data entry from a paper data sheet into your database. Changing the way that we're out there collecting field data are apps. There are a variety of apps out there for tablets or phones that'll help you collect data, whether it's Survey 123 from Esri that helps you design a survey that's going to be geospatial, and so that your data can be tagged to locations and go right into your GIS database, or if you're simply using Google Forms so that your volunteers in the field can simply pull up their phone, take a picture of their site, enter their data in the app. That is another pathway that data might be flowing into your database. If you're collecting samples that need to be analyzed at a state-certified lab, you're probably getting PDF lab reports some weeks after the sampling event actually took place. So you'll have to plan for how you then bring in that data as well. And more these days, folks are really considering auxiliary data. It's not enough to get a complete picture to only look at your data. You can have a much more complete picture of the health of your watershed if you're bringing in data from other sources. So in this example, flow data from NWIS or data from the federal portal. You want to make sure as you're mapping this out, your ultimate end data uses, if you want to put together, say, a very robust report card for your watershed, you will be bringing in data of different types. And so you need to make sure that the data management plan that you put together allows for your acquiring data of different structures and types from different sources. Data quality management or quality control, quality assessment, this is a process that, very similar to data management planning, should be occurring throughout your entire study. Of course, a lot of this gets designed in study design in the early phases of your project. A lot of quality control might be implemented in the field as you're out there collecting samples, perhaps collecting duplicates or field split, things of that nature. Having data sheets approved by an outside person. But when you get to the data entry part, there's additional quality assurance steps that need to be performed there. It's usually a good idea to have a second person. They look at data that has been entered into the database. Depending on what database you're using, you may be able to set up field requirements so that, say, if a field is supposed to be a number, but for some reason there was text entered, that it won't accept it, or it'll flag that piece of data. Or say for parameters that have known ranges, if somebody tries to enter a pH of 15, obviously that's incorrect. So there are some things you can do in data management and where the data is actually housed and processed to help you do some quality assurance of the data that you've already collected. I will say additionally that still past that point, errors still continue to slip through, and oftentimes you don't find errors in your data until you start to analyze and visualize that data and you start finding things like outliers. So quality control, quality assessment really should be occurring throughout your data management process, and you should have mechanisms built into each one of these steps that allow you to go back and make corrections or flag data that seems to have been recorded incorrectly. When you begin to think about your database, there are a ton of options out there, and a lot of questions that you'll have to ask yourself. Whether you are looking for software that you operate yourself that might give you more flexibility or the ability to change your data management over time, or you're really just interested in a service. Let's go to the cloud. One of these folks that have put together an online data management platform. We're never going to tackle this thing on our own. Let's just pay for this and have data management done for us. Of course, there's benefits and drawbacks to each side of these. Your budget may be determining a lot of your database options, whether you can only afford something that's free, and there's some excellent free tools out there, or if you do have a budget to apply towards data management, in which case some of the service options may be worthwhile for you. If you're looking for database management, that is easy. You don't want to constantly be having to retrain staff as they move on or grow through your program. You want your entry-level data managers to be able to come in and use this new system and pick up where your last person left off. Or if you know you're always going to have assigned specialist, someone at your staff, given the amount of data that you're collecting, has database management experience, and therefore we can select a product that gives us more flexibility, more control and we have the in-house experience to be able to manage that. So again, whether something might be in-house or if you're looking to outsource your data management, data that is considered flat versus relational. We'll get into what this means a little bit as we move through the presentation here. But basically, that's the difference between a single spreadsheet or our data has grown beyond a single spreadsheet. We need to know not just what the number was that day, but we need to know what piece of equipment it was, and when was the last time that piece of equipment was calibrated, and what is the EPA method code that it goes along with that parameter. Or you're looking for additional documentation of information about your stations or information about your volunteers. You can imagine if you were trying to put all of that data into a single flat spreadsheet, it would be impossible. So relational databases, as we'll learn here in a little bit, are just databases that help you relate information that is structured a little differently, that doesn't necessarily all be in one place, but is related to each other. Then there are options for where you're going to store it, whether it's local, whether you have a server that you may be able to host a database on, or if you're comfortable going directly to the cloud. A lot of these options should really be dictated by your intended data uses and data users. So again, thinking of that way up front, long before you're selecting equipment or doing trainings or going out in the field to collect this data, if you have uses that you intend your data to meet, you need to start thinking about them from the onset, particularly when it comes down to things like metadata, where a lot of today's presentation will probably be talking about metadata, and that is basically all the data that's outside the value itself. We talked about the EPA method codes or the piece of equipment that you used or how often it was calibrated. These are pieces of metadata that go along with your data to make it more useful to other data users. So you can't just say, submit someone an Excel spreadsheet of a lot of values. It's probably going to raise a lot of questions for them. What was this parameter collected with? And do we know that they're actually maintaining that piece of equipment? And how much training has this data collector had? Metadata is data that goes along with each one of those values that can describe more information about how it was collected. And that just builds confidence in other data users and makes your data a lot more useful to decision makers or other folks who might want to get at your data and use it in their own work. So again, if you have the goal of sharing data and having that data be useful in decision making, you're probably going to be having to collect some metadata that goes along with it, and that probably means you need to start looking at a relational database. So looking at some of the basic types that are out there, again, if your program is primarily around public education, communicating the results of your science to the public, or putting results quickly in the hands of your volunteers they stay interested and engaged in your programs, and you don't have needs for relating additional auxiliary data or sending this data up to the water quality portal, for instance, you may be able to get by with a fairly flat or simple data type, which is going to be this is where a lot of the data exists these days for folks in programs like Excel, or maybe they're uploading it to Google Sheets, comma-separated value documents, things of that nature. You'll notice here we often, the parameters kind of go across the top, and our data just has values, but we don't know necessarily in this structure what was that temperature collected with. Was that a thermometer, or was that a probe? Dissolved oxygen, did they have a stream-side test kit? Was that titration, or did they have a meter? Was that a lab sample? Relational databases basically take tables like the one on the left, and then through a series of unique keys, they will be able to relate that table to another table of information. So for instance, if you have a lot of information about your station, you don't want all that data necessarily in the same table as your water quality information. or if you have data on your volunteers. Again, you don't want all of that data in the same spreadsheet with your water quality information, but you may want them to be linked. You may want to be able to say compare the data between trained or untrained volunteers, or make comparisons between different stations or watersheds or units of time. And having a relational database basically means that you can capture all of this information about your monitoring programs, and they will still be in basic tables, but those tables themselves are connected. In the highest, in the most complicated types of databases that are out there, and I will say that most often what I see are relational databases when they are trying to capture this type of information. But there are other options out there. I haven't seen too many of these implemented yet, but these are these are the cloud-based databases. So things like NoSQL databases, where they're using various program languages like JSON, XML type data feeds, and these are flat. They're not necessarily related because you can't store relational databases just up in the cloud. You actually need servers to operate those. But these types of databases are coming online a little bit more, particularly as we're starting to try to build cloud services and build, say, platforms that might interact with your data through APIs, web services, those kinds of things. These types of databases are out of the grasp for most types of groups, and I haven't seen too many examples of data being structured that way unless it's already in the back end of one of these big data services that we might take a peek at. This is kind of the world that John, who's going to take over in the second half of our presentation, he lives in these structured kind of databases. We'll learn a little bit more from him. So a little bit more about relational databases, just to try to take a little bit of the fear out of some of these, because I'll say that database management is the #1 question that I get from the NGO monitoring community. This seems to be the place where most groups who operate these types of programs really start to run into great technical difficulties. And particularly, it's when they want to try to make the leap to a relational database. So relational databases, like I said, it's when you need to know everything, but you don't need to know it all in one place. And generally, you'll find that whether it's at the Chesapeake Bay program or the EPA's water quality portal, they're all basically using fairly similar relational structures. And it basically breaks down to something happened in the field, you had an event, you had a water quality sampling event, and you collected results that day. And you have a list of stations, and there's information about those stations that you want to track and document. There are projects, programs, and people that you want to document. But again, you don't want all of this information in the same table. You simply want it to be related so that you can use that information when you want to divide up your data or document your data more effectively so that it can be useful to other folks. There are a couple of off-the-shelf data management options that are out there. Some of these are free. Some of them get quite expensive for, say, enterprise-level solutions that maybe a state agency might deploy. And some of these have kind of cheaper options for nonprofits or group rates. But just wanted to point out that there are a couple out there, just so folks are aware of them. There's this Aquam system, and this was developed by the same folks that actually build and maintain the water quality portal. This one is not free for users, but it's a fairly high-level cloud-based data management service that if you have the goal of getting your data into the water quality portal and you've got money to spend on data management, this might be an option for you. There's also something called Open Waters, which is free open source water quality data management. I haven't found a ton of groups yet that have tried to deploy this, so I don't have a lot of user feedback on it, but just also wanted to make sure that folks did know that this was a piece of software that is out there and available. It basically, you can install your own copy if you're able to manage this piece of software, say on a server, or they can pay for them to help you manage the service. So that's getting through, I know it's really quick, but we're kind of burning through data management platforms, but they continue to move along the whole data management regime. Wanted to talk to the point where now you have data managed in a database, and you want to start analyzing that data. So I just wanted to take a moment to talk about the differences between data sets versus databases, as I often see these two often confused. In my work, I usually make a pretty clean division between databases and data sets, because a database is where I will be assembling data, documenting it, preserving it, assessing its quality, and I want to leave it there protected. Versus a data set, where I will often I'll be spitting out a data set that's intended to answer a specific question. So maybe I have segmented some of the data out of my database to produce this data set, and it's processed for analysis. So for instance, I may have excluded all of my sample duplicates so that I'm just looking at my primary samples in this data set. Or perhaps I'm answering a unique question about a particular watershed, or bracket sampling upstream to downstream. Maybe I was only interested in a segment of my data or a segment of time. Data sets are where you get to play. It's where you might be bringing in some additional information to help you make these analyses, but you don't want to be analyzing necessarily right where you're keeping your data. Databases are usually, they're long-term stores, they're for documentation, they're usually relational when they start getting to a certain level of complexity, where data sets are flat. They are single spreadsheet, hopefully designed to be machine readable, which we'll get into in just a second. Now, that's not to say that you can't analyze directly out of a database. You absolutely can. But for most users, I would suggest that they export out data sets to do their analyses. Now, if you've got GIS enterprise level solutions and you've decided to put all of your water quality data in, say, a GIS database, so everything's geolocated and ready for your modeling there, then you're probably doing some analysis directly out of that database as it reaches into it. But again, for most folks, I like to kind of make a division between storing the data and analyzing the data. So when we talk about managing data for analysis, again, they should be kind of assembled to answer some specific questions, usually exported out of your database, often combined with some external data, and they're formatted to make analysis easy. So what does that mean? I get data sets sent to me all the time for help with getting them into better data management systems, or to help out with analysis and visualization. And I see data structured a lot of ways. One thing I see very commonly from folks, if they've been trying to do their own data management and data analysis, that probably means they were operating in Excel. And one thing about doing charts in Excel is that you often start getting data like this, where folks have organized their data in such a way that it makes those Excel charts easy. But now this data can only do one thing, and that's make those Excel charts. So at the point that you wanted to compare parameters across stations or time, or look at more than one parameter at once, this data, as it appears here, is not structured in any way where we can make those comparisons. If you're interested in making those types of comparisons, you're going to have to start from scratch, moving all this data back around into different structures. So there is a structure that we'll get to in a sec that really helps folks take advantage of a variety of data analysis programs and techniques and software. And it doesn't matter where you go, that same structure will work nearly everywhere. Another thing you might want to avoid, and this is kind of like a similar version of the same thing, don't put them on different tabs. Your analysis data sets really need to be in one place, one table of information that you're using to make those comparisons across observations or parameters or stations. So if you start organizing all of your data into different tabs, again, this data is machine readable, but it does not allow for comparing between stations. So at the point that you wanted to say, make some plots that show information across stations or make comparisons between that information, you'd have to start over again with how you're structuring your data. What we like to see for data set is you can call it tidy data. This is a set of principles and software that's included in the R analysis program. And it basically has a couple of major tenets. That means that this data is now cleaned, organized, and prepared in a machine readable format. And if you follow these basic rules, then your data will often be able to be used in a lot more places. And basically that's that every variable should have its own column, each observation should be in its own row, and each value has its own cell. And if you structure your data in this way, a lot of programs are going to be able to use that as a data set. So what is machine readable data? Machine readable basically means that your data is ready to be analyzed, visualized by a wide array of programs and applications. One of the things I typically set groups up with is that they can spit their data out to, say, Google Sheets or Microsoft SharePoint. And we can set it up in such a way it's coming out of their database in a structured format that doesn't change. And we can put that out there on the web, on their Google Sheet, make it available as a web service. And now that means that other programs and other software can reach into that Google Sheet and read that information. And I've taken the same Google Sheet and dumped it directly into a variety of analysis or visualization platforms, and it works perfectly in each of them because it is in a machine readable structure. And basically that means that it's following those same tenets from tidy data. Each column is its own parameter, each observation is its own row, and each value, there's only one value in each cell. When you do this, one reason for this is I will say that data visualization is changing so rapidly. From just a few years ago, where if you wanted to do anything complex or ready for peer review or publication quality, you probably had to be in one of those off-the-shelf data analysis software programs, or you were learning R or MATLAB or something like that. These days, data visualization is changing so quickly, and new platforms are coming online all the time that are based on on reading in machine readable data. That I tell folks, let's really focus on that data management that's spitting out organized data sets, and because your data visualization options might change from year to year as new things come online. This example here is from Google Data Studio, which just came out in the last year. I think it's still considered a beta product, but basically helps you build real-time data dashboards. So a dashboard means this isn't just a static graph. On your website, folks can actually interact with this data, click and drop down different filters, select different date ranges, compare stations, and all of these graphs are calculated on the fly just by reading that Google Sheet. Same thing with ArcGIS. Since ArcGIS launched their nonprofit licenses, we're seeing a lot more NGOs kind of wade into that software, and the new Arc Online platforms, the building story maps and things of that nature, they too can read in a set of data directly from a Google Data Sheet. So that, say an example of as your volunteers are out in the field, they're using a Google form to collect data. That data is flowing directly to a Google Sheet. And then from there, it's updating all of your visualizations on your websites and your story maps, and it's all done in real time. And again, all these tools that we're showing here are basically free. There's some small license fees for ArcGIS, but there are some really, really interesting ways to create fast data flows from collection all the way to analysis by taking advantage of machine-readable data and posting that data online. One of the tools that we've been working on as part of the Water Data Collaborative, but also this partner effort called the North Carolina Aquatic Data Hub, which is a regional collaboration between some nonprofits in the state down in North Carolina, where we're trying to build some tools to help North Carolina programs collect their data in a similar way and then have that data flow directly to the state and to the water quality portal. We are wrapping up development of a distributed access database that's going to help people manage all of this data. This database reaches out to the water quality portal. It reaches out to the National Environmental Methods Inventory to pull in updated lists of method codes and parameter types. It reaches out to North Carolina's web service for bringing in assessment units based on lat-longs. The back end of this is very complicated, but we're building front ends to allow folks at the nonprofits to use this access database to manage their data in a very complex relational database structure, but with a lot of easy to use upfront interfaces for organizing and entering that data. This is something that'll be really consumable, and with some modification, you can set this up to do similar things in other states and regions where it's pulling in data and information that's specific to that state or region. So if you're interested in taking a look at getting a copy of this database, you can contact me. And lastly, data sharing. Just want to talk about why at the Water Data Collaborative, this is our primary goal. A lot of what we're doing is about better resources, better training, removing gaps and barriers for citizen science, but our penultimate goal is to get more data from citizen scientists into these open data portals. And that's because we see what the future is for water data. There's a concept that came out of the Aspen Institute in Duke. It's now officially launched as a program called the Internet of Water. And basically, it's going to be trying to stitch together all of the various sources where water data is contributed in these open data portals, so like the water quality portal, but also groundwater networks or the Western Data Exchange, and PAIN, things of that nature. So yeah, we have the big goal of sharing data to these platforms. Just wanted to point out a couple of them. We've got the water quality portal that you're probably familiar with. There's HydroShare at Quashie. And there's probably also a number of other state portals as well. So if you're in a state that has a place where they're collecting this information, know that the folks of us that are working on Internet of Water are looking at where data is being contributed so that we can federate these large data portals and start creating better tools on top of them to turn it into information. And now that I think I've taken up about my portion of the presentation, and we're going to move on to John here in just a second. It looks like I only have a couple of questions. One was on my audio. Hopefully it's been decent. But that looks like all the questions we've received so far. So at this point, I'm going to turn it over to John. And if you guys have additional questions for this part of the presentation or John's part of the presentation, we'll go ahead and we'll take those at the end. So John, I'm going to go ahead and give you control.
Great. Thank you, Adam. And yeah, I just want to confirm, Adam, that you can hear me. And I'm starting to share my screen now. Cool. All right. Well, thank you very much, everyone. Really appreciate the opportunity to be able to present as a member of the Water Data Collaborative and alongside my colleague and friend, Adam Griggs. So with my portion of the presentation, I really want to walk through a couple of items that I think are really complementary to Adam's excellent synopsis of data management and best practices. And, I think we are chipping away at tackling the data management monster. And, again, great summary, Adam, in terms of getting your arms around the beast. That was excellent. A couple of things that I will kind of walk through today through my portion of the time is really highlighting some of the major components of the data production and data management process. And then talk a little bit about examples of how once you are able to get your data structured in those three respective formats that Adam had shared, really what is possible with respect to visualizing your water quality monitoring data. So just to kind of recap a bit and sort of complement some of the great points Adam made, really with respect to the framework and this whole data management continuum, it's pervasive throughout the entire process of utilizing data with your programs. So in that step one, preparing for data piece, I really feel that that is sort of your opportunity and area to establish a blueprint for the work and the questions that you want to be able to answer with your respective data that you're collecting in the field. And with respect to data from a relational data management standpoint, this is those schemas that we call them, where we're looking at the different relationships between your data tables. This is essentially where you're starting to create the blueprint for allowing your data to answer the questions and maybe even serve the use cases of what you're trying to do with the goals and the objectives of your program. And I think the other point that's really worth reiterating is that at each stage in the process, there is this piece of evaluation and adaptive management. So where it's very, very important to take the time to assess and understand what you're trying to do and the questions you're trying to answer with your respective data, whether it's a data set, a database, or you're building software and applications on top of it. The evaluation and adaptive management component is where you can kind of take the process iteratively. No one is able to get their data structure right the first time. And I would actually say that that's okay. By making sure that you factor in evaluation and adaptive management, you can actually kind of go back, refactor, and change structure, change schema as you need to in order to accommodate the different goals and objectives of your program. And I'll be giving some examples of this as I kind of step through my portion of the presentation. So, again, just to highlight that example with Ron Swanson, for any of you Parks and Recreation fans, I'm a huge fan. We've all been here before where we actually have to refactor things. And again, it is incredibly iterative. I think overall, Adam's definitions of machine readable data is fantastic and holds exactly with how, not just scientists, but also programmers and people that are trying to build active software and systems on top of this data, how they would classify it. In the case of what is really important to talk through today is that step where we will manage data in a structured format, whether that's in a spreadsheet, in a relational database such as Access or SQL, to that last step of making sure that that data can get consumed by different applications and systems online. The core foundation of that is data that is structured and machine readable. And, in the case of, what humans determine as incredibly legible and easy to understand, computers are not quite that good at interpreting these things. So we have to be painfully literal with how data is structured within our systems. And to kind of highlight that across the board, I'm going to actually just jump into a quick example that hopefully is not too repetitive related to Adam's example, but again, kind of complementary. And that is with respect to this sample here with our partners, Blue Water Baltimore, where they've actually started out first with a variety of very structured tables. Adam brought up the really great point about date normalization. So you can kind of see here, these dates are standardized based on, a month, day, and year format. But then the other piece as well that's important to note are things like your station IDs. So if you're mixing, like strings, text strings, as well as numeric values, that you're not doing like a lowercase w and a lowercase b and an uppercase j, because the computer will actually read that as a totally different station versus an all caps station. So, again, it's very, very important to underscore the importance of keeping everything as standardized as possible. And then the other piece as it relates to structure is not just knowing the difference between data that could be considered flat, which, in this case, this is a flat spreadsheet. But when you are looking at and understanding how data is arranged, being able to see where data can be made relational. And what I mean by that is that in this case, every single row equates to a reading where we have each parameter moving across the top. And so in the case of data transferability, if we were to move this data to a relational database, most databases would arrange that information where you would have a readings table. So you would have essentially a list of all of these readings, but then a list of all of the unique stations. And so that's where you can then start to, again, arrange your data in a format that is a little bit more normalized, and that everything fits a specific set of goals and objectives in a given table. And so this is something that, again, arguably is very challenging to do as a small organization where most small watershed organizations are bootstrapped for resources, may not necessarily have the time, but it is well worth the time to sort of think through these strategies and the goals and intents of your respective work. So again, just to kind of move back into sort of what then becomes possible. So just to kind of quickly bounce back to my example here, there's a lot of respective information that can get added into these different data types and these different data formats. And one thing that I think is worth noting is that when you go back to the why you're collecting the information, whether it's to answer a specific question, whether it's to share your data to a data portal, whether it's to visualize it and tell a compelling story, it might even be all of the above. Those questions and those factors play into your respective data schema or your data format. And those things may change over time. So again, going back to the drawing board is a totally legitimate thing. So just as part of this presentation, with the time that I have, I really want to kind of try and get a little bit out of the data weeds and talk a bit about some case studies, a specific case study in one of our applications that is supported through our Water Data Collaborative work, as well as our partners at Blue Water Baltimore. And so in this specific case study, we feel that this is really kind of stepped through the entire process of that flow chart, where you go through the data management and data structuring, and then being able to visualize your specific water quality monitoring data. So we had the great fortune of being able to partner with Alice Volpitta at Blue Water Baltimore, as well as Angela Heron. They have a pretty rigorous monitoring program where they've collected over 33,000 readings across 49 sites in 7 years. And they use this data for a variety of different things. So in the case of Adam's great example, where you have a database that is then fueling many different data sets and many different applications, they've also taken that similar approach where they have an enterprise set of data that they're managing, and then they're using it to to push that information out and serve a variety of different use cases. And one of the use cases that they have instantiated at their organization is being able to conduct monitoring of state water quality standards in the tidal and non-tidal Patapsco. And the protocol that they utilize is the Maryland Tributary Assessment Protocol, where they go out and routinely sample at these 49 sites, and they sample an array of parameters ranging from bacteria to nutrients. And then they utilize the MTAC protocol and the rules in that protocol set forth to be able to create a general eco score or report card grade of their water quality monitoring data. And one of the core pieces, so they manage all of this data locally, and then for the visualization and cloud-based data management component, they rely on the Water Reporter platform. So I'm going to start first with sort of the back end, and we're going to move all the way up to how this data then gets disseminated publicly through the series of maps and information products that Blue Water Baltimore maintains. So in this case, with Water Reporter, they have what emulates really a cloud-hosted data management system. And in this system, Alice and her team are able to sort of efficiently manage a variety of things in the database that map exactly to the things that they're tracking. So in the case of their stations, they are able to basically upload or individually add specific monitoring sites. And so through this, they're establishing their respective site ID, sort of a human-friendly site name, and an optional description. And then they can also be able to georeference that respective site and manage that information over time. Our system does have a variety of automated relationships that occur when you do things like drop a pin on the map. So for example, we're relating the hydrologic unit code based on the NHD, National Hydrologic Dataset, and then that will return the respective watershed boundary. So at each step of the way, they're able to manage their respective site information. And then again, in this relational system, we also have the ability to manage parameter information in units. So, being able to see all of the different parameters that they monitor for. And then in the case where they need to add potentially another parameter that they will sample for on down the road, they're able to create that parameter from within the system. Same thing with units and protocols as well. And then the last two pieces that I wanted to walk through are readings. So in this case, many volunteers and volunteer monitoring organizations that we've worked with, one of the biggest challenges that they face actually is taking a data set such as this one, where they're used to managing these things in flat files, and being able to expand that out into a relational system. Typically, a lot of groups will manage their data where they have specific fields, where the fields pertain to the respective parameter that they're monitoring for. And again, in order to structure data in a way that's relational, we actually have to break that down to its smallest part, being the reading. So if it's a reading, each reading, as you'll see here, is established in a deep format, meaning that this value pertains to this individual parameter that is monitored, CIKI depth. But what's pretty cool about the way that we've tried to structure this is that when you go to actually import a set of your readings, we're enabling people to sort of manage their data in a way that is conducive to their internal workflows, push that up into the system, and then it will actually relate all of that to the station. So what's pretty cool is that off of the data relationships that Adam has shared, things like a station ID and a latitude and longitude are things that we can match off of the reading, and then the system will loop through and start to push the readings to the appropriate stations. So you always know which stations belong to which readings. And then the last two items that I think are a little bit different, and I would say more targeted at people that are excited about visualizing their data, are thresholds and indicators and maps. And this is specific to being able to start to visualize your data. So again, within this cloud-hosted database, we're able to set rules for how data can be scored and visualized. And in this case, each one of these passes and fails pertain to the COMAR standards that are part of Maryland's state water quality standards. So we are able to set up these expressions, give those grades basically give those readings a pass or a fail score, and then that will power an indicator that shows whether or not that station is passing and failing water quality, passing or failing water quality. And in the case of Blue Water Baltimore, what they've been able to do is take take all of their data, push it through this pipeline, and because we have these respective thresholds and indicators set up, we're then able to instantly start to visualize the water quality, based on those COMAR designations. So, for example, if I'm looking at the respective parameter of Enterococcus bacteria, this is based off of the last sample, and then if we go into each one of these stations, we can actually look at an array of other parameters and see how they've stacked up if they were scored based on that COMAR use designation. They're also doing this with respect to report cards, with respect to the MTAC protocol, which is a slightly more complex protocol for ecosystem scores. The other thing too on the back end that I think Adam alluded to that was great was the fact that there is sort of this step of going from database to data that can get passed in a structured way through an API to then being consumed by software and applications. So when he was kind of showing that example of JSON or XML, those are actually data exchange protocols that allow computer software to be able to interact and parse that data. And by setting up what's called an application programming interface, you can actually decouple your database from the software that you build. And so in the case of this map that's being powered by our water reporter backend, we actually have an API that is outputting this data in a way that's structured. And so this is JavaScript object notation or JSON, and that is what will allow our application to sort of parse and make that data easy to interpret by software and different computer applications. So then the last piece is that, we feel going from, it's a long journey from data, from, understanding the why you're collecting data to then being able to collect it into a database, visualize it, and then push it out to applications. We focused a lot on the data interpretation side. And so in the case of these respective maps that we're looking at here, making these systems sort of portable and compatible with other websites and applications. So Baltimore Water Watch is sort of the, I would say, one of the many places that you can actually start to look at data that's collected by members of Blue Water Baltimore. And so it's a very effective and useful way to get the latest water quality in the tidal and non-tidal Patapsco waterways. And it's sort of the centralized place for where individuals can go out and start to disseminate data from these respective programs. So we've tried to make sure that we don't necessarily stop at like the one map and the one application, but build an entire experience around that data and build context so that others can actually know what it is and why it's important, because this is one of the many pieces where you can always collect and manage data for your internal purpose, but connecting it to these larger scale issues is something that's very important and incredibly valuable in terms of volunteer and citizen science. The last point that I'll just drive home before I kind of open it up for questions so that we can get a few in before the 2:30 mark is with respect to connectivity. So again, being able to share data in a way that is sort of real time and parsed through an application programming interface is incredibly important because it allows us to sort of open up the possibilities of what you would use that data for. So sure, like in the case of, if your organization's charter is to measure water quality in a specific watershed, a specific way, by you sort of really focusing on what that intent is and making sure that your data is structured and pushed through either a standardized data set, or if you can get all of the way through making your data available through an API, that means that other systems can actually start to consume that data, consume that information in a way that's structured and that is accessible to others. And, as Adam alluded to, Internet of Water is sort of the main program that's trying to put an amazing rope around that, where, Pierre Colhan, who currently runs Internet of Water and is just a real thought leader in this work, he uses a really great example, which is that, you can search for cat videos online and find them instantaneously. But in terms of doing simple things like finding information about your watershed, who the groups are within your waterway, and the different things that they're doing, that's a tall order. And we have tons of data on that, but it's just not structured in a way that allows us to do those respective things. So, again, the goal is by, following these data management principles, which I understand are like a handful of rules and about 1 trillion exceptions, we're able to make data interoperable and start to really make it pervasive in people's lives. And so I think with that, what I'll do is I'll open it up for questions. If there are any questions on kind of the portion of work that I've shared, or also questions from Adam's portion as well, I'd love to go ahead and open those up. And I'll turn it back to you, Adam, and thanks.
Thanks, John. That was great. So yeah, please do submit any questions if you have for either one of us. We've got about 15 minutes left. I don't see any questions currently in the queue, but if you have any questions about the platforms that we've shown, or general questions on data management, where you can go for additional resources, please do enter them into the chat box. We'll be on for a few more minutes to take those. I do also want to take a moment to plug for the River Rally. Again, I work for River Network. River Rally is coming up June 21st to 24th in Cleveland, Ohio. It's the 50th anniversary of the last burning of the Cuyahoga River. And early bird rate end today. So if you're trying to save some money and you're planning on going to Rally, today is the last day to save some money. Also, we've got a couple of, let's see, if you want more information on the Water Data Collaborative, and we also have the recordings of our previous webinars there, it's waterdatacollaborative.org. John did not get a chance to demonstrate the Clean Water Hub, but that's another data management piece of software that we're opening up. It's very protocol driven to help groups get quick access to managing their data and their stations and get some visualizations out of that. If you want some, you can go to cleanwaterhub.org and talk to us about that. There's also going to be a survey for this webinar. It should be included in a follow-up email that'll go out in about an hour. So we do have a couple questions coming in. So let's see, from Jeffrey Campbell, are the web pages for Blue Water Baltimore based on an available system or something that was developed from scratch for them?
Yep. So I can definitely field that one, Adam. So Yeah, the Harbor Alert site is actually built with two respective platforms. So Blue Water Baltimore relies on Squarespace for all of their web and content, such as copy and images. So that is like a full CMS that they're utilizing, and then the Water Reporter platform is powering all of their data management and maps with respect to their water quality monitoring program. So basically, those two systems can interoperate because we're just passing an embed code for the map to be able to visualize and share that data.
Okay, another follow-up question on the platform from William Rapton. How many developers are working or have worked on the example that you went through?
Yeah, so that's a great question. So right now it's myself and Brendan McIntyre from Chesapeake Commons that are tackling all of the Water Reporter development. We actually have a new developer, Zach Thrun, who is a full-stack engineer coming on board, and he'll actually be helping as well. And then we also have outside of development, full-time user outreach and support on the product. But it's it's pretty exciting. I think as far as the platform goes and development of really any of these products, we're really focused on trying to build development teams and supports around a product that is very focused on a specific area versus trying to build many different custom applications.
Okay, we have a question from Thomas Sola. Any specific recommended data management platforms and experiences leading to that? I'll go first and see if John wants to follow up. I've done nearly all of my data management thus far, including managing some pretty big interstate data sets in Access. So beyond that, I've done a little bit in SQL and MySQL, primarily in my role these days, which is providing support to NGO groups on the ground. I found that if they're going to be wading into managing their own relational database, that usually Access is going to be the best platform for them to start into, instead of if they don't have any kind of SQL data management experience, or they're looking for some of the more enterprise level solutions like Oracle or something like that. So John, do you have anything to add on specific recommended data management platforms?
Yeah, I mean, it's a really tough question. I hate to be dodgy on it, but I mean, for me, it all kind of comes down to like short, near, and long-term goals. I think, starting out first, if you're just starting a program, and you have very limited needs, things like, Excel and Access being a little bit more intense because it's more of a relational system, can kind of get you across the goal line. And then as you start to kind of move on from there, being able to utilize things like SQL is very good in the case of if you're trying to build different applications or systems on top. That offers a little bit more of it offers a little bit more flexibility. And I think the thing to keep in mind is, like, the more flexible these things become, the more technical in nature they become. So, the best thing to do is to always be evaluating your technology stack choices in the context of what your goals are, what you have available funding for, and time, because you don't want to get pigeonholed into something where it doesn't necessarily work for you or your respective goals.
Right, and then another question for you on Water Reporter. What is the benefit of Water Reporter over HydroShare, which is a Quashi product? Yeah.
So, it's a good question. I actually, I've used HydroShare a little bit in my efforts. I sort of see HydroShare as being a really effective platform for publishing data related to your studies and your analyses. It's a great collaboration tool for other scientists that are trying to share data. And then it's also a fantastic data catalog for being able to organize your information. In the case of Water Reporter, we've really focused that at trying to be able to visualize data and sort of uplift the programs of these volunteer monitoring programs that really just need a quick way to be able to show the progress of their monitoring efforts. With the Water Reporter platform, we've actually spent a lot of time in being able to instantly score data. So, basically that map that I was showing with the different report card grades based on MTech and then also COMAR, that's all automated. So they can actually set those rules, and every time they update the system, it'll automatically score. But again, I think it's just slightly solving two slightly different problems that I think are both complementary. And last point on that is that this is sort of where integrations then become like really powerful, because you can sort of piggyback on the benefits that each platform has actually, what they've solved with their development.
And then we have a question from Canada, from Julie Porter. Have we used any of these on transboundary projects? And I would say yes. There's nothing that necessarily precludes the use of these across those projects, and until we get to differences in how, say, geographic data or watersheds are captured and stored. So, for instance, we're using the hydrologic unit code watershed boundary data sets in the U.S. If there's nothing analogous to that in Canada, then you might run into some constraints. I know that in Canada, there's actually a pretty robust data management system that's been deployed in a couple of the major river basins out there called DataStream. So I know they have that up and running for the Mackenzie River, Mackenzie DataStream, and I believe they're working on creating additional instances of that in the other major river basins, if you haven't checked that out before. Another question for you, John. How is Baltimore Water Watch accessed by the public?
Yeah, so that is available through, if you go to baltimorewaterwatch.org, that will take you right to the website, where you can kind of see all of those current conditions and report card pieces. There's also an access data button where if you basically agree to their terms of use, you can openly download all of the data that's powering those maps and access those as well.
Great. And then a question this looks like, I think, the last one we've received so far, from Riley Smith. Is or will the North Carolina Aquatic Data Hub Access Database available as a template and access? And yes, I've already got groups across the country actually working on earlier iterations of that one. We're taking it a step farther in North Carolina to go ahead and pre-program in some of the state protocols that are there, match some of those upfront user forms to the field sheets that are deployed in North Carolina. And the Access database also comes with a couple of specific web service lookups, so it can pull in information like the North Carolina assessment units and other things, other information that makes that data more readily useful by North Carolina state agencies. We are very close to having that completely wrapped up within the next month, and then we will be making that template available. We'll probably have to create a couple different versions of it with some instruction on how to modify it and customize it if you so wish to have those additional functions working for your area. But yes, do stay tuned for that. That is something that'll be just downloadable and ready to go for data management. Okay, and I think that is all the questions that we've received so far. So if that's it, I want to go ahead and just thank everyone for attending today's webinar. I really to John for all of his great work on the Water Data Collaborative and putting together today's presentation. Again, there'll be a survey for this webinar that'll be following up in your email in about an hour. Please do fill that out to help us improve our webinar offerings. And again, additional information on the Water Data Collaborative can be found at waterdatacollaborative.org. And we will also be posting recordings of this presentation up to that website and the River Network website and YouTube channels in the following days. So again, thanks everyone for your attendance. Hope this was a good webinar, and we'll see you guys again soon.